guys, welcome to Code Made Easy. I'm Sagar. Today we are going to discuss another important DSA interview question based on arrays. So this question is going to be kind of very interesting because there are multiple approaches for this question. So without any further ado, let's get into the question. So our question says, write a function rotate that rotates the array of size n by d elements. So what does this question says? It says that we have given an array of integers and this variable d. We have to rotate the array left side by d elements. Say we have 1, 2, 3, 4, 7, and by rotating left side by d elements, our in variable d, it stores integer, and we are supposed to rotate the array by d places. Let's say we have an array of 1, 2, 3, 4, and we rotate the array by 2 places. So our 3 will be coming here, 4 will be coming here, and 1 will be shifting here, and then 2 because 2 will be going to this place, 1 will be this place, and 3 like this. So to understand this problem, let's first discuss how to rotate the array by one. To rotate the array by one place, a simple naive approach will be, in the existing array, you store the first element in a variable, say t, and you simply shift the elements one by one places. Say 2 comes here, 3 here, 4 here, 5, 6, and 7. And ultimately at the last index we are going to store the value of t. So this is the approach to left rotate the array by one. After understanding the algo, let's jump onto the code to left rotate the array by one place. In this code we are seeing that we have a variable I and temp. Temp variable stores the value of array of 0. Let's say we have an array of 1, 2, 3, 4. We stored the value of 1, and this for loop just rotates the same array by one place. Say 0, 1, 2, 3. Our I starts here from the first index and it swaps the element at the 0th index. Let's say it not swaps, it replaces the array at the 0th index. So our 2 comes here, 3 comes here, 4 comes here, and the last line it just swaps the value of t in the array of n minus 1, that is the third index here. So our resultant array becomes 2, 3, 4, 1, which is the required array left rotated by one place. So coming back to our original problem statement, which says that we have to left rotate the array by d elements. So the naive approach to this problem will be left rotating the array by one place, and we have to left rotate it d times. So jumping onto the code for our original problem statement, we have to left rotate by d times. So basically here we are calling the left rotate by one function d times. So this is our main original function which calls our left rotate by one function recursively for d times. Let's say we have an array 1, 2, 3, 4, and we have the value of d is equal to 2. So in the first iteration, we have the value of the array left rotated by 1, which will be 2, 3, 4, and 1. And again, in the next iteration, by this loop, we will rotate our array, left rotate the array again by one place. So basically it will be 3, 4, 1 and 2. And by this ultimately we will get our resultant array as the output, which has been left rotated by the places. So this naive approach, let's discuss about the time complexity and space complexity. The naive approach has a time complexity of order of n square, n into d times. Our left rotate takes order of n, and since we are calling it d times, so it will be order of n into d time complexity, and space complexity it will be order of 1 if we do not consider stack as our recursive stack as our space complexity. Now the interviewer will ask you to optimize your solution. So our optimized or the better approach for this problem will be using an extra array of size d. Let's say the size of d is 2 and our size of array will be 2. And here we are going to store the first two elements, let's say 1 and 2. And in the existing array, we are simply going to store the rest values as it is. Say our 3 comes here, 4 here, 5, 6, 7, and in the next iteration we are simply going to store the value of this temp array back to our original array, let's say 1 and 2, and hence we will get the left rotated array of the original array by d places. See, 1 comes here, 2 comes here, and 3, 4, 5, 6, 7. This is a better approach than the previous one because it uses a time complexity of order of n but a space complexity of order of d. Now the interviewer will again ask you to optimize your solution. So our last and the final optimized approach for this problem will be using reversal algorithm. Reversal algorithm says that we have to first reverse the elements from 0 to d minus 1 elements. Let's say our d is equal to 2. We are going to reverse 0 to 1. And after reversing, we get 2 and 1. And the second iteration, we are going to reverse d to n minus 1 elements. Let's say we get 7, 6, 5, 4, 3. And in the final step, we are going to reverse the whole array. So we get 3, 4, 5, 6, 7, 1, 2. This gives the ultimate array which we are going to which we were expecting. This is the optimized and the best approach because it takes only order of n time complexity and order of 1 extra space. Looking at the algorithm, we this is a 3-line code. Assuming that you know how to reverse an array. So in the code, we have this reverse function from 0 to d minus 1 elements, and then again a reverse function from d to n minus 1 elements, and again a reverse function from 0 to the last element. Let's try run for this algorithm. So let's say we have an element 1, 2, 3, 4, and we have been given d is equal to 3, let's say. So we need to first reverse from 0 to second index, and after reversing we get 3, 2, 1, and again we need to reverse from d to n minus 1 index, that is this one. After reversing we get this only, and at the end we are going to reverse the whole array. Let's say 4, 1, 2, 3, and we see in the original array, if we reverse it by d places, that is by 3 places, 4 will be coming over here, 1 will be coming over here, 2 here, and 3. And that's what we get, and the result output. This algorithm takes only order of n time and order of 1 time extra space. And the reverse algorithm is super easy. You just need to use 2 pointers and then swap the array of low and array of high. This is the ultimate solution, and the interviewer will be super happy with this. So guys, if you like this video, if you like these approaches, kindly please subscribe, share and like our video. Please subscribe to this channel as it encourages us to make more these kind of videos, and we have tons of questions, interview questions like this, and we are going to update our channel regularly. So thank you. Have a good night.